Well, hello Internet, and welcome to part 2 of my Python for Finance tutorial series. This is going to be a regular series. Every Thursday at noon Eastern Standard Time, new videos. And so what are we going to cover this time? Well, I'm going to show you how to download and then clean up over 3,000 different stocks, and along the way go and solve regular problems that would come up in the process of downloading those stocks. And we're going to be using free services across the board, no logins required or anything. Then, after that, what I'm going to do is I'm going to go through the process of going and taking those files, throwing them into a list so that we can analyze them. And then we are going to go and convert those lists into data frames. We're going to create multiple different functions to save our new files with our new information that we generate. We're going to go in and clean up any messed up data. I'm going to show you how to calculate daily returns, return on investments, coefficient of variation, test everything, and a whole lot more. And I have a lot to do, so let's get into it. Alright, so I'm using Jupyter Notebooks just like before, and this is actually going to be split into two different files. First, what I'm going to do is cover how to download all of our data, and I already downloaded it, and it will be available in the description along with all these files that are heavily commented. But I think it's important for you to understand how to download it. So here are all the different libraries that we are going to need. Covered them in the last video. Except these ones are going to be used for saving data to directories. And everything is the same on Windows as well as on Mac. And I know this to be true because I originally did all this on Windows. So here we are. Now, one thing you're going to have to do is we're going to be downloading stock data from Yahoo. What you have to understand is whenever you're installing or downloading large amounts of data, that some of it is not going to get downloaded. So we need to track that. So I'm going to create a list, and I'm going to call it stocks not downloaded. All right, so we have that all set up. And also, I'm going to have a second group that is going to be called missing stocks. Now, what I'm going to do is stocks not downloaded is going to give me all the stocks that I tried to download that didn't go through. I'm going to take that block and I'm going to store them in this master block here, which is going to be missing stocks. And as we go through this, you're going to see both of these lists being populated. Now what we need is a function that is going to save our stock data to a comma-separated value list. I'm going to create a function. I'm going to call it save to CSV and from Yahoo. And there is a little bit of overlap between this video and the last video. And if you didn't watch the last video, you most definitely should. Otherwise, you're probably going to be really confused. All right, we're going to have a folder passed in where we're going to save our stock data. And I'm going to have a ticker. I'm going to have a starting year. I'm going to be working with over 3,000 different stocks. It's basically all the major stocks in the US stock exchange. I'm not going to use over-the-counter stocks because that is going to cause all kinds of problems. And it's probably best not to invest in them anyway because of how volatile they are. And this tutorial is really going to focus on creating low-risk, high-return portfolios. That is our major goal here. So we're going to get our starting year, starting month, starting day, and then we're going to have our ending year. We're going to have our ending month and our ending day. All of that is going to be passed into this function. We are then going to define a datetime object that is going to represent these different starting dates and ending dates. So come in here, do this, and day like this, and then we're going to do the same for end. So I'm going to go grab this and throw this here, and then we're going to go in and change this to end, and this will be ending year, and this will be ending month, and this will be ending day. So there we are. Now what I need to do is go and try to read this data from Yahoo. Now, there could be some exceptions, and that is something that that's the reason why we're using a try block. All right, so it's going to be very important as we download this data that we get some information on the screen saying, yes, we're trying to download the data, calm down. So I'm going to print out which stock that we are specifically trying to download. And then I'm going to go df and go and download. This is going to create a data frame. I'm going to go web. This is using the data reader that we taught, Pandas data reader that we used previously in the last video. And what we want to do here is go data reader, and we're going to pass in our ticker that we want to download. We're going to download it from Yahoo Finance, which is free. And then we're going to define our starting and ending dates. And specifically, what we are looking for is the piece of data called adjusted close. We want the closing price for every single day going back 4 years. So we're going to get a lot of data. Now, one way to try to guarantee that you get your stocks is to pause whenever you go and make your request. So what I'm going to do is say that I want to pause 10 seconds. That's going to cut down on missing data. Then what I want to do is I want to save my data to a CSV file. So data frame to CSV, and this is going to go in a specific folder, and we are going to use the ticker as the name for our stock. So .csv, like that. Then we have to handle an exception that could be thrown. So I'm just going to say except, and I'm going to do a catch-all exception here. We know what the exception is going to be. It's going to mean that, hey, we had some type of problem looking up this stock you requested. So I am then going to say stocks not downloaded, and I'm going to append the ticker. So now we're going to have a running track of which stocks we could not get. And then I'm going to say couldn't get data for, and then we will say the ticker name, just to warn the user so that we have an interface here that's sort of working. So this is stocks not downloaded. You can see this is adding that ticker to that list. And that is how that is all working. Okay, so now what I want to do is return a stock data frame from a CSV file. I'm going to create another function. I'm going to call this get stock and data frame from CSV. So CSV, and I'm going to be passed the folder where I'm going to be getting this information and the specific stock that I'm looking for. Then again, we're going to be reading information, so there's a potential for there to be a problem here. What I want to do is I want to store the stock information in a CSV file as a data frame. So I want to say read CSV and folder plus ticker. Remember, the ticker is going to be the name of the file, and it is a CSV file. So there we are, got that. Now the exception that is going to get thrown here is file not found error, and we want to handle that. How we're going to handle it is we're just going to print out to the user file doesn't exist, and then they can handle it from that point. And then else, if we have no problems, we are going to return our shiny new data frame from our CSV file. Okay, so there we are. We're able to save the stock information and also retrieve it. Now what I want to do is I want to have the ability to return a named column. That just means we're going to provide a column name and we're going to get specific data from that column name. So let's do it. I'm going to create a function, and I'm going to call this get column from CSV. We're going to pass in a file and a column name that we're looking for, of course. Again, we're reading data. Could have a problem here, so we want to wrap this in a try block, and I am going to say pd read CSV and the specific file that we're looking for, and the exception that we could get, we're going to say exception, and it's going to be file not found. So let's just copy this again. Actually, let's go and just copy this whole thing. because it's going to be pretty much the same type of thing. So we're going to say file not found. We're going to say file doesn't exist. Else, we're going to return the data frame, but we're also going to return the specific column name they asked for. So there we are. Got that. So now what I want to do is I want to test receiving the stock tickers. Now what I have is the Wilshire stock list saved as a CSV file. Again, in the description, you'll find the link to this file. So I'm going to create a list, and it's going to be called tickers. And I'm going to say get column from CSV, and I need to point at my CSV file. Now on Windows, you're going to right click the stock and you are going to click on properties. On Mac, you're going to click like this, and you're going to come down, and where is it? Get info. All right, get info, and you're going to find your specific stock right here. See where? You're going to do the same thing, except you're going to do properties inside of Windows. We're going to paste this inside of here. Say users, Eric Pandas, blah, 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 blah. And we specifically want that Wilshire CSV file. So let's go, close this, and works much better on Windows, I think, actually, but whatever, it's the same type of thing. Okay, so we're going to copy this. This is our CSV file, and we're going to paste that inside of there. And if you downloaded the one that I provide, it's going to be exactly the same. And then what we're specifically going to download is ticker. All right, and I'm going to show you why that is. All right, so we have our Wilshire stocks. There is the CSV file. I'm going to open up the Excel file though, and you can see what we're specifically looking at, ticker. This is the column that we want, and we want to save all these stocks in a list. So that's where ticker comes from. Okay, so now what are we going to do? Well, I'm just going to say tickers like this. And you can see there we have our list, and it has every single ticker for all the different stocks. So, and you can see there's some junk in here, which I am going to clean up later. All right, so what do we want to do now? Well, I want to get the first 4 years of data for the first 20 stocks just to test this out. So I'm going to have a folder that I'm going to define where I want all this information saved. And it's going to be in this same general area. So Python for finance, and I will paste this inside of here. Like I said, I have all of this stuff available for you if you want to just download the stock list. But it's very important, obviously, if you're going to start doing this stuff on your own, that you know how to do it. Okay, so Python for finance, and we'll call this stock list, because I already have something called stocks. Okay, so got that, and I'll throw another dash here. All right, so now that we have that, I'm going to cycle through the first 20 of these guys and download that data. So I'm going to say for x in range and 20. That's going to get that for me. And then I'm going to call save to CSV from Yahoo. So save to CSV from Yahoo. So I might as well just copy all this stuff and paste this down here. And I'm going to define the folder where I want this information saved. I'm going to go tickers through our list of stock tickers that we downloaded. And I'm going to say that I want 2017, January the 1st. It's actually January the 3rd is the first day, but it doesn't matter. Through 2021. And I'm going to say 8 and 19. And if you want to be able to work with and get exactly the same results as me, this is what you're going to do. And then I'm going to say finished like this and run it. And you can see it's getting data from Yahoo, and I think this is Agilent, and it's going to download all of that data for me. And there you can see it's continuing to download all of the other additional stocks. And if we go into stock list, don't forget to create your directory name stock list. You can see it's downloading all those CSV files. And if we open them up, you can see that it has both the date as well as the adjusted close for every single day since the beginning of January 2017. And it's continuing to download those first 20 stocks. Actually, I think it's done. All right, good stuff. So there you go. We are downloading all of that additional stock information. Now, what you need to do is go, and what I would do is I would download them in 500 blocks. So blocks of 500 stocks. So to do that, what we're going to do is say for x in range, and we're going to say from 20, let's say to 500, and then we'll say save to CSV from Yahoo, and then we're going to pass in again our folder and the tickers, and everything's the same here. So we're just going to copy this, and we're going to paste this inside of here. See, couldn't get data for AAXN, no problem. Paste that inside of there. And then we're going to, again, print finished after we are done downloading all that information. And then what we want to do also is at the end of that, say stocks not downloaded. And get that list, and then we want to save that list. So inside of the other list that we had, missing stocks, and then we can go and rerun it just on that missing stocks list. So this is going to output that for us. And this is the entire process here. Now, basically, after we do that, I don't want to run this right now, so I'm just going to go B. Then after we go through all 3,000, I think it's 3,480 stocks, we're basically going to do a very similar thing. We're going to go like this. We're going to paste this inside of here, but we're going to say X in, and we're going to say missing stocks. And we're going to get all of those. Again, save to CSV, and we're going to be able, in this situation, instead, however, we're going to say X, because we are using our missing stock information here. We're not using the list that we had. Print finished, and then again, print stocks not downloaded. And if you go and you do that, and you can see there we went and we tried to download 20 stocks and we only missed one of them. So AAXN is now going to be in our stocks not downloaded list. So let's just go down here and let's see if indeed that is true. So paste that there and run it. And you can see the only stock that was not downloaded was AAXN, which we then would save just by copying and pasting it into our missing stock list. And that is the process of downloading. But like I said, I already provided all of those stocks for you. And indeed, this is the main stock list. So here it is. And here is every CSV file for 3,000 some stocks. All right. And this is what we're going to be using for the rest of our tutorial to go through and analyze the stock markets. This is going to be really good stuff and very valuable. All right, so we have our stocks, and what we're going to do, again, on Windows, you're going to right-click and go to Properties. On Mac, you're going to go to Get Info, and you're going to go get this little guy over here, and you're going to copy this. And that is going to be the location for your stocks directory. Now we're going to create another file. I'm going to call it Python Finance.2. Again, exact same libraries as before. And then I pasted in my directory where I have all my stocks. And what I'm going to do here is set some different defaults. And you should do this in a separate file, by the way. So I'm going to have my starting, and I'm going to have these labeled in uppercase, which is kind of facado constants, even though they're not really constants. So I'm going to be using this data a lot. So I want to be able to just refer to these numbers using these default locations. So we have one is January, and then we are going to have starting day, and all of our stock information starts on the 3rd day of January. And then I'm also going to create a string representation of this. So string date or starting date, and this is going to be formatted here with this same information. So we'll have a string representation of our starting year, and we put a dash inside of here, and then we'll have starting month, and then another dash, and then we will have the starting day. All right, so there we are. That is that. That's string representation of the starting from where we are analyzing. Okay, then I'm going to have a date time version of this. So I'm just going to call this starting date, date time, which is going to be equal to date time object. And because we're going to need different forms of this date depending upon which different libraries we're using. So again, starting month and starting day. Now we're going to do exactly the same thing for the ending period of time. And so I'm just going to throw this inside of here, and we'll change this to ending, and it's going to be 2021, and ending month is going to be August, because that's whenever I'm making this. And if you want everything to be exactly the same as me, you're going to use exactly the same dates. And then we just change all these to E's, and we are done setting our defaults, and we'll be able to keep our code a lot neater now. Because if we want to change our starting date, guess what? We do it here. We want to change our ending date, we do it here. And then it works everywhere else through the rest of our code. It just cascades down. All right, all our default values right there. And what did it do? Oh, I forgot to come up here and run that, and come here and run that. All right, now everything's cool. Now, I specifically structured this so that I could show you numerous different ways of working with data. What I want to do here now is I want to go and get my stock file names and put them in a list, but I'm going to be pulling them from the directory where I have them all saved. So how I'm going to do that is I'm going to say files like this, and I'm going to say X for X in list directory, and then I'll have my path where I am going to be storing all that information, which is this. So this is basically pointing at the directory where all of the files are and cycling through each of them. Then I'm going to say if it is a file, what I want to do is join them, and using our path, which is path and X. So what list directory is going to do is return all files in the directory. And then what isFile is going to do is it's going to return true if it is a file. And then what we're going to do is we're going to store its name in our list, which is named files. Okay? So that is exactly what we're doing here at all points. But now what I want to do is I want to remove the CSV extension. So I'm going to create another list. I'm going to call it tickers is equal to. And how I do that is I go OS path and split text and X. And then I will go O, which is going to represent the name, for X in files. All right, so what's going on here is split text is going to split the file name into two parts, being the name, which is going to be whatever it is, A, and the extension, which is going to be CSV. And what we're going to say is we're going to get all our file names, and then we're going to store them in this new list, which is called tickers. All right, and if we say tickers like this and run it, you can see now that we're getting all of our individual stock tickers that we have saved inside of that directory. And if we go and do length of this new list that we have here, and if we look at the number of stocks we have here, let's say get info, you can see that there are 3,052 items there also. So we know that we have every single one of those stocks. All right, so now what I want to do is I want to create a data frame from this list. So to do so, let's just move it up here, and we can say stock data frame is equal to PD and data frame and tickers and columns is going to be equal to whatever the ticker is. So ticker, there we go. And then we'll say stock data frame. And you can see we were able to create a data frame also for that, which is going to be very, very useful. Now what we want to do is create a function that's going to return a data frame from a CSV file. So define, and I'm going to call this get data frame from CSV. It's going to be passed a ticker. It's going to be working with files. So you want to put this inside of a try block. Data frame is equal to PD and read CSV. And we're going to put our path inside of here, plus ticker, plus, and then at the end, of course, it is a CSV file. If we get a problem here or have an exception thrown, it's going to be a file not found error. So we know that that is something we want to handle. And what we want to do in that situation is to just say print and file doesn't exist. And then else we want to go and return it. So this is going to return our data frame. And there we are. Now we got the function that can handle that as well. Now we need a function that's going to save our data frames to CSV files. I'm going to call this save data frame to CSV. And you pass in the data frame and the ticker for the individual stock. And then we can just, this is real simple. We just go df and to CSV and pass inside of it our path plus whatever the ticker is plus again dot CSV. All right, good stuff. There, we got that saved. Now in this situation, I didn't have this problem, but it is very common whenever you're downloading data from the internet that you're going to have things called unnamed columns. So what I want to do is I want to cycle through and delete any unnamed columns that are inside of my data. Again, I'm preparing you for multiple different circumstances. To do this, you just say data frame is equal to data frame and location, and we're going to go and specifically look for columns that are named, that have the unnamed, okay? So, and we'll do tilde like this, df dot columns dot string dot contains, and this is going to be unnamed. Now, I have done worked with Yahoo Finance. Sometimes this is a problem, sometimes it isn't, okay? So just be aware of that. And we're going to say return and spell return correctly and return our data frame. All right, so we got that set. Now what I'd like to do is also be able to come in here and add daily returns for all of our data frames. Now you may or you may not remember from the previous video, but I talked about how to calculate simple rate of return by getting the ending price minus the beginning price divided by the beginning price again, okay? So that's what we're going to do here. So I'm going to call this define add daily return to data frame, and it's going to be passed in the data frame and a ticker like this. And what it's going to do is it is going to get our data frame, create a new column called daily return. And I like to, whenever I'm adding to columns of data, I like to use underscores and otherwise not. All right, and that sort of provides me real quick way of saying, okay, well, this is the original data and this is the data that I used previously. So we're going to be using adjusted close to make this calculation, divided by, and again, it's going to be the adjusted close, except I'm going to get the previous day's adjusted close. And how you do that is by going shift like this and 1. And then what we're going to be able to do is subtract 1 from that and get that piece of information. And then what we want to do is save this data to our CSV file. So dot and to CSV, and again, pass inside of it our path, plus our ticker, plus, and again, our CSV file. And there that is, and then we can return our data frame. And there that is. All right, so now what we're going to do is create another function, and what it's going to do is return the investment over time. And with a return of investment over time, sometimes people get a little bit confused about how it works. What it's going to do is it's going to return the return, like the extra return that you received from your investment, not including the initial investment. So for example, if you invest $100 and after 5 years, it's now $200. Well, return on investment is going to be whatever the ending value is, minus the initial value, divided by the initial value. And if you do this, you get a value of 1 comes back. Well, you'll now know that your new total is going to be your initial investment, which is $100, plus this 1 right here, whatever the return on investment was, which in this situation is 1, times the initial investment, which gives you 200. All right? So the initial investment or return over time, the return on investment is going to be that additional $100 that you got. All right. So what we want to do is we want to calculate that as well. So let's create a function again. Get return over on investment and defined time, because we're going to say over what time period are we working with here. And this is it's going to be passed a data frame. So what I need to do here is I need to set date as a date time object. So date equal to and PD dot to date time and data frame, and again the date. So there we have that. Now I'm going to come in and I'm going to define my start value, which is going to be df and df date equal to. So we're saying if it's equal to this starting string is what we have to use in this situation. You saw us set those up before. We are specifically then looking for adjusted close and our first bit of data. We're going to do similar things for our ending date also. So throw that there. Let's change this to ending value. So ending value. And again, this is going to be date, except we're looking for our ending date. And everything else there is exactly the same. And then after that, I can come in, maybe I want to print and say something like initial price and output that. So we'll say start value. And then we're going to also go and print and we will say final price. So final price, and that will be ending value like that. And then we can calculate our return on investment, which is going to be equal to the ending value minus the start value. And then both of those are going to be divided by the starting value. And then at this point, we can return our return on investment. And there we are. Whoops, what'd I do here? Oh, I forgot that this is going to be equal to, so we're matching up these dates. There we are. And now it'll work. Okay, and now we're going to get our coefficient of variation. And I talked about this in the previous video. This is going to show us how much risk we have with our portfolio, taking into effect the different price levels of stock. So you have a $2,000 stock, just watch the previous video if you don't remember. So I'm going to show you how to get that coefficient of variation. All you need to do is pass in our stock data frame. And then I'm also going to need to calculate our mean. So the stock data frame, and we're specifically interested in adjusted close. And if I want to get the mean value for all the adjusted closes, well, guess what? That's what I do. Standard deviation, which is going to be our risk, but it's not going to take in account the different prices and such. This is going to be like the dollar amount that this is going to fluctuate. So standard deviation, that's how to get that. And coefficient of variation, which is a nice smoothed out way of measuring risk, is just standard deviation divided by mean. And then we can return our coefficient of variation. All right, now it's time to test these functions. What you want to do though, before you do this, make a backup of this folder right here. So let's go and make a backup. I'm going to say duplicate in this situation. There we are. Because if you mess this up, you don't want to mess up all of your previous downloaded code. That would be a nightmare. All right. So you spent all that time downloading all those stocks, or you just download them for me. Either way, you don't want to be messing that up. So what I want to do is I want to get the very first ticker that we have. So tickers and 0. Let's run that. And in this situation, I think that's Cisco. All right. And then what I want to do is I want to get a data frame for that ticker. So I'm just going to call this stock A, whatever. And how I get it is I say get data frame from the CSV, and I'm going to say tickers like this. And if we go stock A like that, file doesn't exist. Let's see what's going on here. Guess what? Why they did that? Because I didn't have up here with path, I didn't put this final /. So make sure you do that. Okay, so we got that set, and you can see here is now our data frame for our stock that we were working with. Good stuff. Now what I want to do is I want to add my daily return to that specific data frame. So I'm going to say add daily return to data frame, and I'm going to pass in stock A and tickers and 0 like that. Okay, so that's good. We can then say stock A like this, and now we have the daily returns as well as the adjusted close. Now let's say that we want to delete any unnamed columns that are inside of here. So we can say stock A is equal to and delete unnamed columns like this, and stock A like that. And we don't have any, but you know, if we did, they wouldn't be there. Okay, so then after that, we can go and save our cleaned up data frame to a CSV file. And to do that, we say save data frame to CSV and stock A like that, pass in our ticker like that, and like this. Whoops, what did we got here? And I just put in an extra underscore. Get rid of that. Sorry about that. Bring us down here, and let's run it again. And if we then come in here, go into stocks, and open up Cisco specifically, you can see that we have our date, adjusted close, and daily return. So great stuff. And now all we need to do is add daily returns and clean up all our files. So to do this, we're going to say for ticker in tickers like this. And it's probably a good idea, so you don't lose your mind, to go and output. So we'll say working on, and we specifically want to say what ticker we are working with. So you'll get constant feedback. Then what you want to do is get a data frame for this ticker. So we're going to say that we want to get this guy, and we'll copy this, paste that inside of there. Same stuff. The only difference here is this is going to be stock, and I'm going to call this data frame. And I am going to be passing in the ticker as we cycle through every single ticker that we have. And then we need to add our daily return again. So we're going to grab this, and we're going to come down here. We already know this stuff works. It's always best to test it though. So stock data frame like that. And then this is, again, ticker. So there's this. And then we're going to go and get this guy also to get rid of any kind of garbage that's inside of there. So again, this is going to be stock data frame, delete unknown column or unnamed columns, data frame like that. And then we are going to save our clean data frame to our CSV file. So again, grab this, paste that inside of there. And this is going to be stock data frame and ticker like this. And there we are, and we can run it. And you can see it's working on every single one of those. All right. And I think that's a good place to stop off here. And in the next tutorial, what we're going to do is start comparing returns and covariance and variation for numerous different stocks. So hopefully you found this tutorial useful. And like always, please leave your questions and comments down below. Otherwise, till next time.